DEN 161 Product for Final Project by STEM 7. What is our product? Our product is an electromagnetically propelled train made by coiling wire around an iron core and then hooking each end of the wire to a 9-volt battery. Then we use the magnet to push the train around the track. Our product was designed with certain criteria in mind. We had to make sure it was cost-effective, educational, fun, safe, easy for a 6th grader to assemble, and it had to align with a grand challenge. Here is a video of our electromagnet pushing the train.
So how well the product functions. We have plenty of design criteria, so I'm going to talk about each one specifically. First off, fun. As you can see by our decision matrix, we had this as a high priority. We wanted to make sure that it was fun and that kids found interest in it, so we went with magnet. Magnet levitation is something that really anybody of any age will find interesting, so using electromagnets and bringing that into what we were trying to do, we knew was going to be something that'll hold the interest of people of any age, but especially 6th graders. When it comes to costs, we only spent $16 out of our $25 budget. You can see the pie chart on the right is breaking down the specifics of where we spent our money. A majority of that money was spent on the train and tracks just because that was a pre-made kit that we used compared to some of the other things were more just raw materials. So you'll see that those took up a lot less, like the wires is something where you can buy it raw, especially in bulk, and is very, very cost effective. For educational, obviously magnets is something that generally people have a little bit of understanding for, but electromagnets, especially to a 6th grader, is something new that they don't really have very much of an understanding for. So allowing them to create the electromagnet is teaching them how it works. Obviously they're going to learn a lot there. The rest of it, the train and the tracks, is more simple, but still, even with the tracks that we had, you'll run into some problems with geometry. So all of that allows them to pull something educational out of our product. For safety, obviously the main concern would be that we're working with electricity. So for our setup, it's very low voltage. This means we're at really low risk for things like shocking or wires heating up or things of that sort. And all the materials used are relatively light. Nothing is really sharp edged. Nothing can be swallowed or anything like that. The train tracks are made out of a light piece of wood as well as the train. For our assembly limit time, the limit was 10 minutes, and our testees were able to complete our product in 7 minutes. So long enough that you're getting close to that time without getting over it, and obviously that's going to vary depending on the kid and what sort of challenges they run into with ours. For Grand Challenge, so restoring and improving urban infrastructure. Most infrastructure now is trains, especially maglev trains, are gaining popularity, even decades ago, and still continuing to grow just because of their efficiency, their ability to eliminate friction, and also their simplicity. So giving kids that just basic background knowledge of how those work is something that'll help them out someday, hopefully, when maybe they're trying to improve and advance that technology. As far as advanced personal learning, this is something that gives multiple different challenges. You have the challenge with building the electromagnet, setting up the wire, making sure that the battery's on correct. Even just making the train track can be generally difficult, just with the way the geometry is set up. But there's multiple different ways where different people can grow in the ways that they personally need that advancement and growth, and so it is very personalized. That's pretty much everything. And also you can see at the bottom here that we have our decision matrix that kind of explains everything and why we went originally with magnetic levitation, which eventually kind of turned into what we do now with the electromagnet.
Why is our product worth it? It's worth it for many reasons, the first being that it helps children learn with something that isn't typical, electromagnets. This is important because it allows them to dive deeper into specific STEM-related activities. And this is great because it'll help them get into more STEM-related careers and help shape our future. This product is also worth it because it effectively taught the kids about how to safely work with electricity while being something that they enjoyed. Nobody wants to work on projects that are boring, so we found something that wasn't boring and still taught the kids what they needed to know. And that's why our product is worth it.
As you can see, our product hits all of the requirements of a great product. It is highly rated in fun, education, and cost on the decision matrix. Speaking of cost, our product only costs around $16 to manufacture. If you sell it at $25, you can make a 36% profit at $9 per pop. It also encourages children to get into STEM and is an engaging way to teach kids about magnets. We offer you a fantastic business opportunity and we're excited to hear back from you. Thank you for watching and good night.